So if you have not watched previous introduction video, please watch the introduction video. I have given the link in the description. Then you can watch this video further because it is related to the it is continuation part of the previous video. So watch first previous video and then continue with this one. Okay. Universal gas constant we have seen in the previous video. It is given in the 8.31 kilojoule per kg mole Kelvin. Then ideal gas equation, when the whatever the liquid is there, it is converted in the form of the gas. Then the ideal equation we get is PV is equal to nRT. We will be using. So by the gas laws now, let us see first law, that is Boy's law. So according to the Boy's law, at the constant pressure, sorry, constant the absolute pressure of an given mass of a perfect gas varies inversely with its volume when the temperature remains constant. Means at, at the constant temperature, pressure is inversely proportional to the volume. Pressure is inversely proportional to the volume. So this is the symbol of the proportional. When we are writing, we have to write it like this. We can read this one as a pressure because here P is the pressure. P is what? Pressure, and V is the volume. And pressure and relation between the pressure, Boyle's law has stated that pressure and volume are inversely proportional, and the temperature is constant. Temperature will not going to vary. So to in order to remove the proportional sign, we can write PV is equal to constant. Constant, because here it is already is divided, then it will be multiplied to the other side. So at constant temperature, pressure pressure and volume is equal to constant. Okay, so this equation only can be written as P1 V1 is equal to P2 V2, or else further P3 V3 you can write, so on. So here once again they have given statement: when the temperature remains constant, pressure increases as the volume decreases, vice versa. Both are varying in the opposite directions. The next law is the Charles law. So according to the Charles law, the volume of a given mass of a perfect gas varies directly with the absolute temperature when the absolute pressure remains constant. That is, volume is directly proportional to the what? Temperature now. So in order to write this as volume increases, pressure temperature will be increasing. As volume decreases, temperature will be decreasing. So this is what happens in the Charles law. So to write this one in the form of equation, you can write, to remove that proportional sign, proportionate sign, V. So when it moves to the other side, it will be divided by. So it is constant. C means constant. So this equation only you can write in terms of V1 T1 is equal to V2 T2, and it will be always equal to the V3 T3. So on you can write at constant. It is at the constant pressure. Pressure is constant. Remember it. And here temperature is constant. Temperature is constant in the Boyle's law. And next, after that comes the Gay-Lussac's law. In this statement, volume is constant. Volume will be constant, and so all the perfect gas. Okay, it states that absolute pressure of a given mass of a perfect gas varies directly with the absolute temperature when volume remains constant. Means pressure varies and with the respect to the temperature, that is at the constant volume. As pressure increases, temperature will increase. As pressure decreases, temperature will decrease. So this is what happens in the Gay-Lussac's law. So to remove the direct proportionate, P by T is equal to C. So this equation only you can write P1 T1 is equal to P2 T2 is equal to P3 T3. So these are the three laws of the uh, perfect gas laws. We can call these as the. So if if we want to see some problems on this, uh, let us let me explain you some problem on this. First of all, okay. So here a gas occupies 2 meter cube at a 300 degree Kelvin. The volume at 450 Kelvin. Okay. So certain gas is there. It is occupying some space. So if I take in a container and in this there is a gas and the it is 2 meter cube volume is there. So we can say this as a V1. Okay. And its a temperature is 200 300 degree Kelvin. So we can say it as a T1. So then find the volume at 450. 450 degree Kelvin means that is a T2. At this temperature, what is the volume you need to find? Okay, I will write it properly once again here. So first of all, we need to mention the given data. So given data will be V1 is equal to 2 meter cube, T1 is equal to 300 Kelvin, T2 is equal to 450 Kelvin. So at this temperature, we need to find V2. So as per the Charles law, we are having this equation V1 T1 is equal to V2 T2. So here V1 we are having, we have to substitute this one, and we are having T1, we need to substitute here, and T2 is there, we have to substitute, we have to find V2. So if it is not given temperature in the Kelvin, then you need to convert that one. In some other videos, next upcoming videos, I will be explaining. So please go through that. Some complex problems also I will explain. These are very much simple problems. So complex problems I will explain the upcoming videos. Go through those. So here, as per the Charles law, V1 T1 by V2 T2, we are having the equation. So here, once we substitute these values, if I calculate these terms, so how to calculate? So first of all, you have to 2 by 300, 2 divided by 300 is equal to V2 it is. So here I am sending this 450, it is there, I am sending it to the other side. So when I send this one to the other side, it will be multiplied. So it will be multiplied here 450 because it is divided by to the other side and then becomes V2. So you have to calculate this one with the bracket and whole term has to be divided by 300. So after operating the calc, you will get V2 is equal to 3 meter cube is the answer. At 450 degrees Celsius, the volume will be 3 meter cube. So this is the how we have utilized this law to identify the volume at second condition. Then if I take another problem which is on the Boyle's law, here they have said a gas occupies 0.5 meter cube volume. So volume on this meter cube only you can identify that it is a volume. So this will be V1. I will say it will be 0.5 meter cube. Okay, and the pressure at that volume is 200 kilopascal. Okay, 200 kilopascal, and the pressure at second condition, that is 500 kilopascal. It is, find the new volume at this pressure P2. So you have to find the V2 for this one. As per the law, what is the equation we are getting? P1 V1 is equal to P2 V2. So we need to substitute these all the values here. V1 here, then P1 here, then P2 here, and we need to find this V2. So we will substitute these all in as they are given, because uh, here we don't need to convert any units, or else any value we don't need to convert, because pressure are on the both side and volumes are on both side. So directly we can get the volume answer in terms of the meter cube, so that why we don't need to convert. So if there are any problems where the conversion is needed, means that pascal to the newton per meter square, or else kilopascal to the some other unit, kilonewton per meter square, if you want to convert, then definitely such problems will be explained in the upcoming videos. Go through those complex problems. I will give the links in the descriptions of the problems. So here, when we solve this one, so simple, remember, when we are solving, 200 into zero point 0.5 is equal to 500 into V2, it is there. So I have to send this one to the other side to solve. So if it here, it is the multiplication relation, so it will be divided to the other side, 200 into zero point 0.5, and it will be divided by here the whole. So into V2, in sorry, is equal to V2. So whatever the answer you will get for this one is the V2. While conversion, taking any unit to the LHS to the RHS and RHS to the LHS, you need to remember what the things will going to happen. If the certain value is multiplied here, then it will be divided to the other side. So when you solve this one, you get 0.02 meter cube. So this is the answer. Next problem, let us see on the Gay-Lussac's law. So uh, here they have given a gas has a pressure of 100 kilopascal. So I will say it as a P1, 100 kilopascal, it is, at the temperature, that is 300 Kelvin. It has been given here also. The units already they have been given in the Kelvin. If it is given the degree, you need to convert it to the Kelvin. Otherwise, some in such a equation wherever both sides, if you are getting that same temperature T1 T2, then no need to convert, directly you can place. But when you are using only temperature 1, or else temperature 2, at that time you may need to convert that into the degree Kelvin, to the degree Celsius to the degree Kelvin. So here already it has been given, no need to convert that one. So here pressure P2 is 450, sorry, T2 it is, sorry, I will say it as a T2 because it is a temperature at Kelvin. Find the pressure at the, you have to find the pressure at a temperature this 450 Kelvin. So to find this one, you can use the Gay-Lussac's law, because here volume we are considering as a constant. Volume is constant, so you can use this equation P1 T1 P2 T2. So here P1 is given, here P2 is given, sorry, T1 is given, P2, sorry, T2 is given. So you need to find P2. So in order to find the P2, it will be 100 into 450, then 300, because this will be multiplied here. It is divided to this side, on other side it is divided. When it comes to the this side, this will be multiplied. So this is P2 value. So what is the P2 value here? 150 kilopascal you are getting. I hope you have understood the problems, you have understood the laws here, three laws, simple problems you have seen. Some complex problems also you will see in the next videos. The link of that complex problems I will be giving in the description. You please go through that one.